Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today we are mastering LeetCode 53, the Maximum Subarray Challenge. This is a fundamental dynamic programming problem that tests your ability to find optimal patterns in linear time. Let us look at the problem statement. Given an integer array nums, our goal is to find the contiguous subarray which has the largest sum, and return that sum. A subarray must be a continuous part of the array, no skipping elements allowed. Think of it like a professional athlete on a winning streak. Every game they play can either add to their reputation or hurt it. If they have a series of good games, their momentum builds. But if they hit a massive slump that wipes out all their previous success, they are better off forgetting the past and starting a fresh streak from their next good game. We want to find the single strongest period in their entire career. This brings us to our strategy, Kadane's algorithm. Instead of checking every possible subarray, which would be too slow, we use a greedy approach. We maintain two variables, current sum and max sum. As we walk through the array, we ask ourselves a simple question at each step: is it better to add the current number to my existing streak, or should I throw away the past and start a brand new streak with just this number? We start a new streak whenever the previous streak becomes negative, because a negative sum will only drag down whatever comes next. Let us dive into the dry run. Look at the screen. We have our input array, -2, 1, -3, 4, -1, 2, 1, -5, 4. At the top, and our running total bar at the bottom. We initialize current sum and max sum to the first element, -2. Moving to index 1, the value is 1. Should we add 1 to -2? That gives us -1. Or should we just start fresh with 1? Obviously, 1 is better than -1. So we reset our streak. Our max sum updates to 1. At index 2, we see -3. Adding it to our 1 gives -2. Starting fresh with -3 is even worse. So we keep the -2 for now, but our max sum stays at 1. At index 3, we hit 4. 4 plus -2 is 2. But starting fresh with 4 is much better. We start a new streak at 4. Max sum becomes 4. Now at index 4, -1. Adding it gives 3. Still positive, so we keep the streak alive. Max sum remains 4. Index 5, 2. 3 plus 2 is 5. Our streak is growing. Max sum updates to 5. Index 6, 1. 5 plus 1 is 6. Another new peak. Max sum is now 6. Index 7, -5. Adding it drops us to 1. We keep the streak, but the record stays at 6. Finally, at index 8, 4. 1 plus 4 is 5. Our walk is done. The highest peak we ever recorded was 6. Now, let us look at the Python code. We initialize current sum and max sum using the first element. We loop through the remaining numbers, updating current sum by taking the maximum of the current element itself, or the current element plus the previous sum. This is the start fresh or continue logic. Then, we update max sum if our current sum has reached a new record. Looking at the complexity, the time complexity is O of n, where n is the length of the string, because we traverse the array exactly once. The space complexity? O of 1. We only need two variables to keep track of the sums, regardless of how large the input array is. And that is the Maximum Subarray Challenge mastered. Save this video for your next technical interview, and follow Leo Academy for more such premium DSA guides.